So let's have a quick look at the calendar. So we are, let's see, we're right here on the 18th. We're going to finish chapter 4 today. Tomorrow will be a Q&A day, so we're also starting the project. So if you come to class tomorrow with all of chapter 4 done, including 4.4, then tomorrow we can take questions on anything that we've gone over. We might be able to look at some ePortfolio stuff, look at the second project. You could get started on that. Use your time wisely there. And then we're going to start chapter 5. We're going to do 5 sections in chapter 5. Let's see, 6 sections in chapter 5. And then we've got a test 2 weeks from today. Okay, so make sure you keep track of those. That happens to be during parent-teacher conference week, so it would be nice if you have a good score for that. And then we've got that Friday off. The next week is a 3-day week. And we've got fall break on the 11th and 12th. So at this point, we're about halfway through the semester. Okay? So that'll be kind of cool. Semester. Yeah, right there. Because that's about 8 weeks in, 7-8 weeks in. It's about halfway through the semester. College semester, not high school semester. Okay. Okay. So I'm hoping this section is pretty easy. You actually use these skills in the project that you're going to start tomorrow. Thank you. So you want to make sure that you understand these really well. So this section is on linear inequalities. So the starter question is, how do we solve inequalities? In a nutshell, how do we do it? Just like we solve equations. Just like we solve equations. Okay? And then I'm going to write except, dot, 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 all that stuff. If you multiply or divide by a negative, you've got to switch the direction of the inequality. Okay? So if I said, well, how do we graph inequalities then? Just like we graph equations. Okay? So we're going to be doing the same type of thing. So if you can graph a line, you can graph a linear inequality. Okay, remember, if it's a line, it's just y equals. It's an equality. If it's a y less than or equal to or greater than or equal to or something like that, then it would be what we call a linear inequality. Okay? So we'll graph a linear inequality just as if it were an equation. Okay? We usually, although not always, we usually put it into slope-intercept form in order to graph it, because that's a really nice graph-friendly form of a linear equation that you're all familiar with. Okay, but before we graph it, we need to decide a couple of things. The first thing is, will the line be solid or dotted? And then the second thing is, which side of the line will be shaded? Because when we're doing an inequality, when we're graphing an inequality, you're going to have to do some shading. So we've got to figure out, do I graph a solid or a dotted line, and then which side of the graph do I shade? Which side of the line do I shade? So for the solid or dotted question, we look at the inequality. Now these two types of inequalities here, this is a greater than, this is a less than. Okay? If you have one of those things, you'll notice that it can't be equal to the line. So since it can't be equal to the line, then we do a dotted line. Okay? These are called strict inequalities. So strictly less than that, can't equal it. Strictly greater than that, can't equal it. Okay? If I have a greater than or equal to or a less than or equal to, that equal to part is the part that allows us to graph a solid line. So if it's a greater than or less than, it's going to be a dotted line. If it's a greater than or equal to or a less than or equal to, it's going to be a solid line. And then the question is, well, which side do we shade? Okay, and I think this is an easy way to figure out which one we shade. So let's say I draw a line and it looks like this, whether it's solid or dotted. If it's greater than, like if it's y is greater than x plus 3. Oops, let me do a greater than. Okay, if it's y is greater than x plus 3, what we do is we put our pencil on the line, and then if we say y is greater, y is in the vertical direction. If I say greater than, do you think I go up or down? Up. So I go up. That puts me on the correct side of the line, and then I'd shade this side right here. So if it's greater than, shade above the line. And if it's a less than, then we shade below the line. Okay? It's that simple. We're going to graph it just like we would a line. All we have to do is it solid or dotted? We talked about how to figure that out. And which side do we shade? That's it. Okay? So, for this first problem right here, it says determine whether each ordered pair is a solution of the given inequality. Now, I'm actually going to graph this on the xy plane. We're going to plug this in just a second, and we're going to see whether or not it's a solution, but we're also going to do this graphically. So, I usually put these into slope-intercept form. So I'm going to take this, and there are a couple different ways that I could do this. If I move the 2x to the other side, I'm going to do that by subtracting 2x. So this is going to be minus y greater than, because remember, I didn't multiply or divide by a negative. So this would be a negative 2x minus 4. Notice I'm kind of putting this in descending order. I'm writing the x term first and then the constant on the end. Now, is this in slope-intercept form? Not quite, is it? What do I need to get rid of next? Got to get rid of the negative. So I'm going to get rid of the negative by dividing both sides by -1. Now, what's the step I'm taking to solve the inequality? Dividing by a negative. If we divide by a negative, we have to switch the direction of the inequality. So this is going to be a less than positive 2x plus 4. So, solid or dotted? Dotted, because it's a strict inequality. It has to be, the y's have to be less than the line. So let's graph the line. It's going to cross at 4, and it's going to have a slope of 2. So that means rise 2, run 1, rise 2, run 1, or down 2, back 1, down 2, back 1. So it looks something like this. So I'm just going to draw a dotted line there instead of a solid one. Try and be as accurate as you can. Put arrows on the end. And then to figure out whether we graph above or below, put your pencil on the line, and then it says y's less than. Go straight down. So if we go straight down, we're on this side of the line, so I'm going to shade it like this. So this is the shaded area. Now I can kind of enhance that because we've got this nice little feature here. There we go. That is the answer. Dotted line, shaded area over here. Now, the question on this one was, determine whether each ordered pair is a solution of the given inequality. Well, there are two ways that we can figure that out. One way would be to take this, there's the x, there's the y, and plug it in and see if it actually works. If we've already got a graph, remember, if a point's on the graph, then it works in the equation. Or if it's on the graph of the inequality, if it's in the shaded part of the inequality, then it would work in the inequality. Well, let's graph this point. -2, 3. So that's back 2 and up 3. That puts me right here. Is it in the shaded area? It's not. So is this a solution? The answer there is no. Let's just double check this. If I plug in, let's see, a -2 here, 2 times -2 minus, so this is going to be minus 3 greater than -4. So let's see, that is -4 minus 3, that's -7 greater than -4. Careful here, is -7 bigger than -4? No, the answer there is nope. So it's not a solution to the inequality, and you could see it here. It's not on the shaded area of that linear inequality. Any questions there? Okay, let's take a look at the next one then. So I've got 3 graphs at the bottom here. This is not a strict inequality, so is this going to be a solid or a dotted line? Solid line. So it crosses at 0. Slope is 1/2, so I'd rise 1, run 1, rise 1, run 1. So it looks something like this. And again, when you draw this line, you want to be as accurate as you can. Go through the correct points. So this is like the border between the things that work and the things that don't. So we draw the line, put our pencil on the line. We want the y's to be greater than. So if the y's are greater than, once I'm on the line, I go straight up. That's on this side of the line, so it's this area right here. That's the answer. Any questions? Pretty easy? Hope so. I'm hoping you can get a lot of the assignment done. The problem with this one here is It's not written in slope-intercept form, so I'm going to move the x over by subtracting an x. So I get y. Do I have to switch the direction? Nope, because we didn't multiply or divide by a negative in solving this. I'm going to write the negative x plus 4. I automatically know that this is going to be dotted. It's going to cross at 4. Slope is negative 1, so that's down 1 over 1, down 1 over 1, down 1 over 1. Same thing going the other direction, only it's going to be back 1 and up 1. So my graph looks something like this. Read from the variable that we're interested in. We want the y's. We want to know whether we shade above or below. So y is less than. Pencil on the line. The less than direction would be down. So we're going to shade this area right here. Okay? Any questions? Okay, would you do number 19? Check with your neighbor. See if you got the right answer. If you both got the same thing, then you're probably in good shape. Should work out fairly nicely. Again, check with the neighbor once you got it. If you go both got the same thing, you're probably right, but double check. Can you tell whether it's solid or dotted just by looking at it? Yes. Can you tell whether you shade above or below just by looking at it in this form? Yes. Okay, on this one you can, okay? But I'd be really careful with this because on this one we never end up multiplying or dividing by a negative. So you can tell whether it's solid or dotted. I'd hold off until you get it in the correct form to figure out whether or not it's shaded above or below. So this is going to be 3y minus 2x and a positive 6. That's still going to be a less than. When I divide by 3, that doesn't change the direction, so I know I'm going to shade below, right? So this is going to be negative 2/3 x. There's the slope, and then this is going to be plus 2. So it crosses at 2. Rise of negative 2, run of 3. So it's going to look something like this. Looks a lot like the last one, doesn't it? Something like that guy right there. And we're going to shade below. So there's our graph. Easy enough? Okay, flip the page over then. You do end up with the occasional oddball. There are always exceptions to the general rules that we talk about. So if you're talking about shading above or below on these, that's fine. But the problem is, the steeper the line gets, people start getting confused and they say, well, wait a minute, do I shade above or below here? So on this one, if it were greater than, I'd definitely shade above. Put your pencil on the line, go up above, shade here. If it's a less than on this one, put your pencil on the line, go straight down, you'd shade on this side. If on this one, okay, if we said, gosh, it's less than, I'm going to shade below, so I'm going to go straight down or something like that. But the steeper a line gets, the harder that decision is to make for some people. No matter how steep it is, as long as it's a slanted line, if we had y is less than 100x plus 2, slope's 100, that would be ridiculously steep, but it's still got a slope, right? Put your pencil on the line. Even if it's really steep, this is a less than. Which way would I go, up or down? It's a less than. I'd go down, so I'm shading right here. I'm shading on this side. Now, it looks like I'm shading on the right side, but I'm not, because if I exaggerate the slant, it's still below the line, okay? The problem comes when we end up with a line that's straight up and down. Because if you use that rule for a line that's straight up and down, put your pencil on the line. Let's say it's a greater than. Greater than means move up. If I went straight up, I'm still on the line, okay? So you should notice something about these lines right here versus this one. These would all be y equals. What if it's vertical? Then it's x equals. And to be a vertical line, it's got to be x equals a number. So if we happen to come across a vertical line, graph it just like you would anything else. So if it's x is greater than 2, graph the line x equals 2, dotted line of course. And then the question isn't do I shade above or below the line, what's the question then? Which side, either left or right, okay? So if you have a vertical line, the question is do I shade to the left or the right? If it's greater than, do you think it's left or right?
Right.
Yeah, because if we're thinking about the x-axis, the greater side is on the right, and the less than side is on the left. So if I have this one right here, I'm going to graph this like I would x equals negative 2. So negative 2 on the x-axis, go as far up and as far down as you want. Solid or dotted?
Dotted.
Going to be dotted because it's a strict inequality. I put my pencil on the line, and because it's straight up and down, I'm not going up or down, I'm going left or right. And this is a greater than, so I go to the right. That means I'm going to be shading this side right here. If I do the next one, I'd graph a line at 3. Solid or dotted? Solid line at 3. Pencil on the line, and the question is right or left. And on this one, it's also on the right. Okay? All right. Any questions? Pretty easy? Okay. Only have 3 more problems to do. Okay, are there any questions on anything we've gone over? Because the rest of this I'm hoping is pretty easy. Okay. These are systems of inequalities. So these are kind of like two-dimensional compound inequalities, if we could use that phrase. The word that connects every one of these is and. I want this to be true and I want this to be true. This to be true and this to be true. I want this to be true and this to be true and that last one to be true. So here's what we're going to do. Okay, I'm going to graph these in different colors. I'm going to do this one in red, and I'm going to do this one in blue. So you'll notice that this is already in slope-intercept form. They're both going to be dotted lines, so let me graph the red one. The red one's going to look like this. It crosses at 0, the slope is 1. So I rise 1, run 1. So I've got these points, whoops. I've got these points right here. So we'll do a dotted line. Put my pencil on the line. It's y, so I'm going to move in the y direction, either up or down. It's a less than, so I'm going to shade this side. Then I'm going to do the blue one. It's already in slope-intercept form. It crosses at 1. The slope is negative 1, so I'm going to rise negative 1, run 1. Rise negative 1, run 1. So it's going to look something like this. Again, it's dotted. Put my pencil on the blue line, read from the variable that we're interested in. Y is greater there. So am I going to go straight up or straight down? Straight up. So I'm going to shade all of this over here. Now, what does the word and mean? Both. It has to have both types of shading. Okay, so I know you're graphing this really well and all that good stuff. Can I get your attention for just a second? Everybody look up here. Okay, please don't forget this, because I have students forget this all the time. Doesn't matter how far they've gone in math, they forget this. If a point is on the graph, then it works in the equation, or the inequality in this case. So anything that's shaded will work in at least one of the inequalities. So this one here has blue shading. Anything here will work in that blue graph, or excuse me, work in that blue inequality. This has red shading. It will work in this one. This has no shading. It won't work in either one of those. Any point you pick in here won't work in either one of those. Okay? We want points that work in both. If you want points that work in both, it's got to have both types of shading, so that's going to be this area right here. So what I'm going to do is I'm going to grab this. Now, the borders are really important. This border is dotted. This border is dotted. And this is where it has both types of shading, so this stuff right here is the answer. So if this were a test question and you wanted to make sure you got this right, I would probably lightly graph the blue one, lightly graph the red one, and then once you figure out where the answer is, shade the whole thing in really dark. Okay? Any questions? Okay, some people get carried away when you start throwing these together. Remember, this was a dotted line to begin with. It's still dotted. This was a dotted line to begin with. It's still dotted. Okay? Good? Okay, watch please. One more quick point. What about this point right here? Right at where those two lines meet. Does that work in the inequality? Okay, I hear a bunch of no's. Can somebody tell us why not? Tyler.
The line isn't solid.
The line isn't solid. If the line were solid, then it would work. Okay? So let's take a look at the next one. Again, this is already written in slope-intercept form. What would the difference be between this type of system of equations and this type of system? Yeah.
The lines are really solid.
The lines are going to be solid. Now, do I need to do this one? Is everybody okay? Just pop your hand up if you want to see that real quick. Okay, then let's move on and let's do the last one. Okay, so I'm going to use 3 different colors here. I'm going to use green, blue, and red. Now, these hopefully aren't any problem. I'm going to take the green one and I'm going to solve that. So let's see what we get here. If I do the green one, I'm going to get 4y greater than negative 3x plus 12. If I divide everything by 4, I get y is greater than or equal to negative 3/4 x plus 3. Is everybody okay with that work done in my head? I did it right, didn't I? I'm prone to make mistakes here with numbers. Struggle with that. Good? Okay, solid or dotted? Solid. So we're going to go up here to 3, 1, 2, 3. Slope is negative 3/4. So I go down 3, run 4. Down 3, run 4. So my graph looks something like this. If I go up 3 and back 4, I'm going to do, oops, I said it was solid, right? Ooh, that's a mess. Okay, that's what that looks like. Now, again, I would lightly shade to begin with. That solid line is fine, but I'd lightly shade. This is y's that are greater than, so it's going to be above. So I'm going to do this kind of lightly. Okay. Now we'll do the blue one. If I move the 5x over to the other side, this is going to be 6y less than or equal to negative 5x plus 30. Divide by 6. Do I need to switch the direction of the inequality? Nope. Negative 5/6x plus 5. So this one crosses at 5. Solid or dotted? Solid. Slope is negative 5/6. Okay, so this is a little bit of a pain. Negative 5, go down 5 over 6. So we're about right there. So this solid line, gosh, are these parallel? Not quite. But that is a solid line right there. Okay? And shade which side? Careful. Less, so that would be below the blue line. So that's going to be, again, I'll do it kind of soft. That's this stuff right here. So if I stopped at this point right here, what would be the answer? That little sliver right here, everything in between here, it would be that, right? Okay, but I'm not done. I've got one more set of inequalities to graph. So these are x greater than or equal to or x less than or equal to. If you have x equals a number, what type of line is it? What's it called again? Vertical line. So we've got a vertical line. So I'm going to take the red here, and I'm going to graph 1. 1 is right here. I'm going to graph 3. By the way, I didn't ask, but it is solid, isn't it?
Yes, it is.
Okay. And I want the x's that are greater than 1, so that's going to be on the right side of this line, and less than 3 on the left side of this. So if I shade this in just lightly, where's the answer now? The answer now is just this little thing right here, from here to here to here to here, and everything inside that. Okay? There's the answer. So if you make these kind of light, it's a lot easier to see what the solution is once you've done graphing it. Okay? Now, the weird part about this is, correct me if I'm wrong, but pretty much, well, everything on the graph that we can see, everything is shaded, but only this is the answer. Can anybody remind us why? Zach?
It has to be for every single question.
That's the only place that has points that work in all of them. So anything that's shaded with green, shaded with blue, shaded with red, it's got to work in all of them at the same time. Okay, are there any questions? Okay, that's it. You've got about 20 minutes left, a little more than 20 minutes. That's enough time to probably come close to getting done. Okay, listen up. Listen up. Little hint on Math Excel, I mentioned this before. You're going to have a little paint bucket in the palette so that you can draw the line, either solid or dotted, and then dump paint where it's supposed to be shaded. Leave the bucket in the shaded area. If you take the bucket and move it outside the shaded area and have it check the answer, it thinks where you put the bucket should be shaded. So leave the bucket in the shaded area. It should be okay that way. All right? Okay, thanks.